Okay, so let's see if we can do 2.4 number 7. So we're supposed to solve the IVP. Y prime minus 2y is xy cubed, and we have an initial value of y of 0 is 2 root 2. Okay, first things first. What do I do?
Find the homogeneous solution.
Okay, I think probably I do maybe one dumber thing first. When you're confronted with a differential equation, the first thing we want to do is try to identify what kind of thing am I dealing with here. You guys with me on that? Okay, so what kind of thing am I dealing with here? How about what order of differential equation is this?
First.
Good. So I'm looking at that and I'm seeing that this is a first order
nonlinear.
Nonlinear. Wait.
No, I think it's linear but non-homogeneous, isn't it?
Well, it has the y on the other side, so I figured it would have been nonlinear.
Yeah, so this component here, this y cubed, means that this thing is nonlinear. You guys with me on that? So once it's nonlinear, I have a pretty limited set of tools to deal with this. You guys see that? So if it's nonlinear, I only have a couple options. The first option that I have is maybe it's separable. This one doesn't happen to be, but we could try that. What other options do you have for nonlinear?
Is it called Bernoulli equation, or does it have a different name to it? Because that's the only name I know from the textbook.
No, that's good. That's one. Yep. So for nonlinear options, you have a couple things. Maybe it's separable. Maybe it's Bernoulli. Or maybe it's homogeneous nonlinear. Two of these you learned in this section. Which two were in this section?
The Bernoulli and homogeneous nonlinear.
Yep, perfect. So at this point, I'm like, okay, it's a first order it's first order nonlinear ordinary differential equation. Okay, so now I have these three options for those things. I don't see that this is separable. Is it Bernoulli? What does a Bernoulli thing look like? Anybody?
It kind of just looks like a linear equation, but with a y on the right side to a power other than 0 or 1.
So it looks like a first order linear thing, right? So like y prime plus p of x y. And that's going to equal some function of x, say f of x, times y to a power r. Should be noted, r is not 0 or 1. Because in the case that r is 0, then this is just a linear non-homogeneous equation. And in the case that r is 1, what is it? If this was just a plain y over here, Why would I not need a Bernoulli technique for it?
So it would be
Nip-
separable.
Separable, yeah.
Yeah, it'd be separable, or you could just subtract this to that side and see that it's linear homogeneous. Right? Okay, so what else? So this is what I'm looking for Bernoulli. Does this thing fit Bernoulli?
Mhm.
Let's see. Got a y prime over there? Yep. Is it added to some function times y? Yep. On the right-hand side, you got some function of y times y, or sorry, some function of x times y to a power that's not 0 or 1. Yep. Okay. This is Bernoulli. All right. Now that I've identified it, then your step is to implement the technique. If you don't go through the identify step, sometimes you will accidentally start executing a technique that doesn't apply. If you start executing a technique that doesn't apply, it doesn't tend to work. It does oftentimes yield a bunch of work to do, but then it won't get you an answer. Does that make sense? So that can be a very, very frustrating experience. All right, so how do I actually apply the Bernoulli technique? Jacob, you started off on a good thought. What was it?
Solve the left side as if it was a homogeneous equation.
Okay, so let's consider y prime minus 2y equals 0. How do you solve this thing?
Add 2y to the other side and divide by y. Then integrate both sides.
Okay, so we're essentially treating this as separable, right? Okay, so we got y prime is this, so then we divide by y, so we got 1 over y dy is 2 dx. Slap some squiggles on here. Say the natural log of the absolute value of y is 2x plus a constant. I hope that you guys are bored of these problems now. Is that true? Okay, if it's not yet, it will be. All right, this is like the integrated polynomial kind of thing. Like, you're going to do it a lot. I want you to be bored to death of it because I want you to get it right every time without thinking about it. So then I exponentiate both sides, so I get y is a e to the 2x. Everybody with me on that? You can, if you want, just memorize the form for first order linear things and jump straight from here to there. That's totally fine with me. You guys good? I would recommend actually memorizing the form. It does make your life a little easier. Okay, so what's my next step? Now that I found y was a e to the 2x,
Turn that a into a u of x.
okay. And this technique is going to be called variation of parameters. We're going to do it a lot. So I want to just have that name. So I'm going to say y is u thought of as a function of x times e to the 2x. So this technique going that way is going to be called variation of parameters. Why is it called variation of parameters?
Because you're varying your parameters.
Yeah, you're letting the parameter vary. It's not a creative name. It's also a technique we're going to come across a million times, so it's also one worth memorizing how to do. Okay, so I've got this u. Now what?
Well, you can substitute y back into your original equation, but you also want y prime. So you're going to want to take the derivative of that.
Okay, so I need the derivative of this thing. So y prime is going to be u prime times e to the 2x plus u e to the 2x. What did I forget?
The 2.
Okay, times 2. This is just the product rule. Everybody good with that?
Also, may I make a note
No.
real quick, Joe? While you're reading my homework, if you actually do, forgive my notation because I literally I keep it as C and then treat C as a function of X without changing it to something else. So you're welcome.
No, you don't do that. That makes me so sad. C prime should be 0.
Well, too bad. C prime is C prime.
Ethan, don't do that. Name things well. You code enough to know that.
Hey, I put a little symbol in it that tells you it's been translated to function space, okay?
Mm-hmm. Yeah. I see. You're writing this. Define constant of X.
Basically, at one point, I actually, in one of the problems, I wrote assert and then put a condition in it.
Gross. All right. Don't do what Ethan does. Be a kind, considerate human being.
Never do what I do. Doesn't matter what it is, just never do it.
I'm not sure I'd go that far, but all right. So we did the product rule. We got this. Now what do I do with this?
Plug it back into the original equation.
Good. So we're going to go get our original equation. I'm going to call this thing star here. We're going to take these two items and we're going to plug them into star. And so that's going to become u prime e to the 2x plus 2u e to the 2x. So that's my y prime. Minus 2, and then I have u e to the 2x. So all this stuff was y prime. This one is y. And then this is going to equal, and on the other side of this equation, I'm supposed to have xy cubed. So I have an x, and then I'm supposed to have y cubed, which is going to be u e to the 2x cubed. Pretty good with that? So this whole side is xy cubed. Good? Okay. Now, I'm going to notice that some stuff cancels, and this is the beauty of variation of parameters, is that stuff always cancels here. So these guys are going to cancel against each other. And then I'm going to be left with u prime e to the 2x is x u cubed e to the 6x. Guys good with that? Okay, next step. What's next?
You can separate.
Yeah, now we can separate variables. So I'm going to have 1 over u cubed u prime is e to the 4x. Oops, and an x e to the 4x. So that's do some algebra, right? Okay, so I did some algebra. Now I'm going to multiply both sides by dx. So I'm going to go, guess I'm going to have u to the minus 3 du is x e to the 4x dx. And then I'm going to slap some squiggles on both sides. What do you get out of this?
Well, the left side is negative 1 over 2u squared.
Is wait, what?
U to the negative 2.
Okay, so I do one higher power, right? So that's going to be u to the minus 2.
Yeah.
And then what do you do with the one higher power?
Divide it.
Okay.
That's what I said.
Oh, is it? Sorry.
Negative 1 over 2 u squared.
Oh, I see. 2u
Oh,
squared
I
is
see, I see.
one
Yeah.
single term.
Got it. All right, so you got this is, and on the other side, we're going to need to do a little integration by parts. Bummer. Okay, so what's your integration by parts look like?
It never gets better.
I would probably pick oh god. All right, I use my own notation. But let's see. It would be u equals x.
Let's see. So the thing I want to differentiate is x, right?
Yeah. So
And
equals x,
then-
and then dv is e to the 4x.
Is everything else good? And so v is, and I guess maybe I should put some kind of notation on this thing. So that's going to be v is e to the 4x over 4.
Yeah.
And du hat is 1 dx.
Yep.
And so I'm going to get the, let's see, uv is x e to the 4x over 4 minus the integral of v du is going to be minus the integral of e to the 4x over 4 dx.
Swear, if this comes out to me actually having the right answer, I'm going to be upset because everything is what I have so far.
Uh-oh.
The only problem is at the very end, I have a 0 in my bottom half of my fraction.
Okay.
When I plug in
Uh-oh.
the initial values, I get a 0 in the bottom.
Oh, okay. So let's see where we get here. That makes me scared. Oh. Where's my keeper of the 0? Do I not have a keeper of the 0 vector in this class?
Assigned one. I don't know who it was.
Oh, drat. Well, we're going to find out why you need one.
Oh, hold on. I think you assigned one in linear. I don't think you assigned one in this class.
I was going to say, I think that was just linear.
Okay, well, when we get to the end, somebody's going to be the keeper of the 0 vector here. All right, so I got to here. And since I'm kind of illustrating how this process goes, I'm going to just keep hammering on this thing, even though I realized it's not going to help. So I got u to the minus 2 over minus 2 is going to be x e to the 4x over 4 minus e to the 4x over 16 plus a constant. And then we need to solve for u here. Let's see. So first things first, I suppose I want to multiply everything through by negative 2. So we're going to make that a 2 and flip the sign and fiddle around with some numbers here. Okay, so I have 1 over u squared is minus x e to the 4x over 2 plus e to the 4x over 8 plus a constant. Everybody on board with that? Okay, so then I need to kind of flip things over and take a square root. So I'm going to get u is plus or minus the square root of 1 over, and I just want all this crap.
Never mind. I see where I went wrong now. You probably shouldn't get a 0.
Oh, I think I probably do.
Oh, okay.
Okay, so now all this stuff, right? Let me guess, you just flipped over the pieces individually?
Yeah.
Yeah, don't do that. Okay, so now this is the answer to u. So Now, in the end here, I really wasn't answering a question about U, right? I should have been answering a question about Y. You guys all see that? So originally this was a function about Y. I got this U thing, but I made that thing up. So I need to know what to do with this. So what do you do with this whole thing?
Substitute it back into.
Yep. So back up here, variation of parameters. At the end of variation of parameters, you get Y is your function U, which is this whole thing, which I can't make much smaller without making it illegible, times e to the 2x. You guys all see that? And there's some manipulation you can do with this thing if you want. The problem I think I'm going to have is that when I plug in, I'm supposed to plug in y of 0, right? Oh, no, I'm okay. Never mind. Forget it. It's all good. The problem I thought I saw isn't here.
Yeah, because all you've got is e to the something underneath, and that's not going to cause any problems because the bottom can never be 0.
Yeah, so I know that I'll talk about what I thought was going to be the problem here in a second. So I know that 2 root 2 should be y of 0. So if I take that and plug it in here, right, I'm going to have plus or minus the square root of 1 over, let's see, that's going to be 1 over 8 plus c times 1. Everybody with me on that? Okay, and then I can tell that I needed to pick the positive square root. So I know that I can say this has to be the positive square root for this to work. And then you can figure out what c is here. So in order to figure out what c is, I should maybe square both sides. So I'm going to have 8 is 1 over 8 plus c. And I'm pretty sure that means c is 0 by inspection. Everybody going along with that? I don't really care how you guys do algebra or arithmetic. I trust that you can do it. So you get c is 0. So that means that my solution is ultimately, in the end here, I got y is the square root of 1 over minus x e to the 4x over 2 plus e to the 4x over 8 times e to the 2x. Nasty, horrible looking function, but there it is. You can certainly do some like algebra magic to make this agree with what's in the back of the book, but it should. Now, what is the thing I thought I saw that I was scared of for a minute? So if I go back and look at the original equation, this guy, for whatever reason, when I was looking at that and Jacob said that something weird had happened, I double read the 0 here, and I thought that this read y of 0 is 0. If you had 0 in here, this wouldn't work. You guys see why? Because I'd have 1 over something equal 0.
Mm-hmm.
Why wouldn't it work? What is the problem? Well, in that case, I would want to check and see if the 0 vector or the 0 function satisfies this equation. Does the 0 vector solve this? Or the 0 function solve this?
Yes.
Yeah, it does.
Yeah, it does. So the constant 0 function is a solution to this thing. So even after all this variation of parameters, right, I got to here. And this is not quite the complete solution because also y is constantly 0 solves this thing. You guys see that? And I can see from the kind of, well, I don't really have an existence and uniqueness theorem for this one yet. But when I do have an existence and uniqueness theorem for this one, I would see that there should exist a unique solution. You guys see that? And so I know that I'm not going to get anything that has y of 0 equals 0 except for the constantly 0 function. You guys see that?
We'll take your word for it.
Okay. Who changed their username to Zoom is garbage?
I did, because for some reason Zoom consistently crashes for me, and then I have to go join the web browser, and I was like, there's already a Jordan in there. I'll be Zoom is garbage.
Okay, makes sense.
Yeah, and also I can't turn on my camera because it keeps on acting weird with Zoom.
Okay.
I hate it so much.
Okay.
Yeah, whenever I would try to use Zoom video in the web browser, it would just crash the page after like 15 minutes.
Nice.
Yeah,
It's crashing my app and page.
all right. So any more questions about this problem in particular? Okay.